Hello everyone, this is Shiryan Soni, student ID 253777738, and today I'm demonstrating a real-time glass rendering system that implements physically based reflection and refraction with Fresnel effects. This project showcases how light interacts with transparent material using OpenGL and GLSL shaders. First of all, let's start with understanding reflection. Let's start with pure reflection. When light hits a glass surface, some of it bounces off. This is reflection. You can see the environment mirrored in the object. Notice how the object acts like a perfect mirror, showing the surrounding environment. The reflection follows the laws of reflection. The angle of incidence is equal to the angle of reflection, and as I rotate the camera, you can see different parts of the environment reflected on the surface. Now let's start with refraction. So what happens when light passes through the glass? When light enters a transparent material, it bends. This bending is called refraction and is controlled by the index of refraction, or IOR. Every material has different index of refraction. These index of refraction follows Snell law, which is n1 sine theta is equals to n2 sine theta, where thetas basically tell you how much the light will bend depending upon the property of the material when entering another medium. So if I adjust the refraction slider, we can see that at IOR1 there is no refraction and it looks like there is nothing, or maybe a little bit it looks like there is a bubble. If I remove chromatic dispersion as well, you can see there is nothing there. It almost looks like there is nothing there. If I add a little bit of chromatic dispersion, you can see there is a little bit of bubble-like feeling. At 1.5, we get glass. And at 2.4, we get a diamond-like feeling. So at higher IOR values, light bends more dramatically. The chromatic dispersion I was talking about is the rainbow-like color separation at edges. This, just like a prism splitting white light into colors, different wavelengths of light refract at slightly different angles. Red, green, and blue separate, creating that characteristic rainbow effect you see in real diamonds and glass and bubbles. We can see that by increasing or decreasing the chromatic dispersion slider, I can change how much rainbow effect we are noticing in the objects. Now let's talk about the Fresnel effect. In reality, materials don't just reflect or refract, they do both. And the ratio changes based on the viewing angle. This is Fresnel effect. The Fresnel effect states that surface becomes more reflective at grazing angles. Look at the center of the sphere versus its edges. So now in the center, if I see, it's mostly transparent and we see refraction. But at the edges, where our view is nearly parallel to the surface, these are highly reflective. This is exactly how real glass behaves. The Fresnel equation is basically performed by this function in my shader. And this basically translates to f is equals to f naught plus 1 minus f naught into 1 minus cos theta to the power of phi, where f naught is the base reflectivity and that theta is the viewing angle. Now this f naught, I have made it controllable so that we can see what happens at different f naught levels and can we go from no reflectivity to complete reflectivity. So as I go from 1 to 0, you can see that it completely goes from a reflective model to a transparent model, and there is pure refraction happening at this point. So it looks like glass but with no reflection at all. And as we move from 0.0 to 1, we can see that all refraction has gone, and now we see complete reflection happening, and all it becomes like a perfect mirror, showing no transparency. Usually at 0.5, this is the Fresnel blend point. We can see both reflection and refraction angles working together with Fresnel effect, determining how much of each based on viewing angle. By adjusting this parameter, we can simulate different material properties or artistic effects. In physically accurate rendering, F naught is calculated from the material's IOR, but having manual control, let us explore the full spectrum of effects. So to summarize, this demo shows pure reflection using environment mapping, pure refraction with chromatic dispersion, the Fresnel effect blending both based on viewing angles, an adjustable F naught parameter to control the reflection-refraction ratio. All this is computed in real time using fragment shaders, demonstrated the power of modern GPU accelerated graphics for physically based rendering. Thank you for watching.